Hello folks, welcome to Delmi Training Institute series of training on electronics. And in today's video, I'm going to be talking about relays, how to connect a relay to control a couple of electronic devices. My name is Roland, I'm with Delmi Solutions and Delmi Training Institute. So today's video, I'm talking about the RDC 12. It's a two-part relay module. It's got the base and it's got the actual relay module. So I'm going to explain how to connect this to control some electronic devices. So join us on this journey. All right, folks. So as I mentioned, the first thing I always like to do is to take a look at the data sheet. The data sheet is a very important piece of any electronic component or any other device because it explains the feature sets of what you're going to be working with. So first of all, I'd like to go over the data sheet, what it says. So like I mentioned, this is an Ultronics RDC 12. It's got a relay and the base module. When you purchase it, that's how it comes. You find these two in the package. This relay in question, I'm going to zoom it in a little bit so you guys can follow along with me. It has it's UL Underwriters Laboratory. It's recognized by them. It's CSA approved, which means that it's approved for use here in Canada by the Canadian Safety Association, and it's been approved. And this particular one is a 12 volts DC operation. There are two different types. There's one also which is a 24 volts DC operation, which means that you need 24 volts to energize the relay. In this case, we are using a 12 volts, so please make sure that you check what the voltage requirements are before you attempt to connect it. The current draw on this particular relay is going to be 86 milliamps, so not too much of a current draw. And it's able to switch a maximum of 10 amps at 220 volts alternating current, or you're able to switch 228 volts AC with a double pole, double throw contacts. So we're going to look at what that means in a second. It's also DIN rail mountable, which means that you can attach these two places to a DIN rail and use them in an industrial setting. It also gives us the dimensions that we need to know. Okay, so that is a little brief of the data sheet. Now on this, it gives a description of what the coils are and what the terminals are for. So these terminals are labeled 1 through to 8. So with 1 and 2 being our normally closed, 3 and 4 being our normally open poles, and 7 and 8 being our coil, and 5 and 6 being the common poles that are going to switch between the two throws that we have. Like I said, this relay is a double pole, double throw. What is a double pole, double throw? A double pole, double throw means that it's got two poles and it's got two throws on the circuit. So what we're going to be looking at is these are going to be independent circuits and they do not have anything to do with the opposing sides of the circuit. So when I bring in a voltage on the common terminal here, I'm going to experience that voltage on our normally closed. And once the relay is energized, I'm going to see that voltage switch to the normally open. That is when I'm working in a wet instance. For dry relay, this is also known as a form C, meaning that it's got a pole and a throw with a common. Now let's just jump right into how to connect this. So first of all, I'm going to take the relay module itself and plug it onto the base. And there is only one way that you can get this plugged in, so you cannot make a mistake with this. So it's got these two pins that are oriented differently from the ones on this side. And when I get the relay as well, I see these two are oriented differently from all these ones. So I'm just going to take that, align them, and gradually push it in. And that fits my relay, and that is it. Another thing I want to talk about is when you look on the data sheet, all these numbers have been written on the relay base, and it's a little bit difficult to read, but when you pay close attention to it, you are able to read that. So upon zooming in, we are able to see that this is number 7, that is number 5. This one here is number 6 and number 8, and so on and so forth. So when I align the relays to correspond with what's on the diagram, this happens to be my number 3, number 4, number 1, number 2, 7 and 8, and finally I have the 5 and 6 on here. So with my 5 being the common for this right side of my circuit, and this number 6 being the common for the left side of the switch, we're going to see how to do them. Now it says 7 and 8 is my coil, and what that actually means is 7 and 8 is my input. Now let's go back to the data sheet. On this side of the data sheet, it makes us aware that the relay will activate upon applying a 12 volts DC to the terminals marked 7 and 8. Which means these are these two terminals. So when I apply 12 volts DC to these terminals, I'm going to see this relay module toggle between the normally closed and the normally open of the throws. So let's take a look. So what I want to be able to demonstrate is I want to be able to make or break the circuit. So I'm going to need to use a switch. And this is the switch I'm going to interface between my power supply and relay terminals 7 and 8, so that I can also demonstrate how the pole shifts between the two throws. So let's take a look. So first of all, what I'm going to do is I'm going to take power from my power source. Just for this purpose, instead of using a power supply, I'm going to be using a 12 volts Ultratech battery. It's a 7 amp hour. And it's rated for 12 volts. So what I'm going to do first is I'm going to take the positive terminal of my power source and I'm going to connect that on. So since I'm using that, this is what I'm going to do. Now I have a switch and I'm going to use the switch to make or break the circuit. So also I'm going to take the positive from here and I'm going to connect them together. Most of the times I use these connectors to connect two different wires, and I've been using these for a very long time. I'll post the link to where you can get them to purchase. They come in very handy and they make connections, electronic connections, very easy. So I'm going to plug the first one in here and close that, and as you can see, it makes a very good connection. So I'm going to take the other side of my positive wire and I'm going to connect it to the side and click that. So now I have a connection from the battery all the way to the switch. And this switch that I'm using is just a regular on and off switch. Now, if it's in the off position, no current is going to flow through this terminal. However, when I turn this on, I'm going to allow electricity to flow through this. So in the moment, I'm going to turn it off. Now I am going to take this relay, and because these are my two terminals, I'm going to connect one of it here. So I'll grab my screwdriver, loosen this terminal a little bit, and just slide this in. The datasheet makes us understand that these two terminals are non-polarized. Non-polarized means I can either connect my positive terminal here or on this side. It really doesn't matter. They're not polarity sensitive. So I'm going to connect my positive here. Sometimes when you're working on stuff like this, it gets a little bit confusing because I get asked that, oh, why are you using black to represent positive? It's just because I'm going through the switch and this is what comes out. If I had a different terminal, I probably would have used that. Okay, I just found a red one, so I'm going to use that to continue so that there's no confusion as to why I'm using the black to it. So I'm going to connect my red to it like that and connect my red to the positive terminal. Usually when I make connections, I don't want to have cables exposed like this because you end up short circuiting your circuit. So I always want all the exposed copper to go in like that. So I'm just going to screw this terminal up like that. And I have a secured connection. So that happens to be the positive terminal that is coming from the battery all the way here. In a similar fashion, I'm going to take another terminal, which is the negative, and I am going to connect it to the negative terminal of my battery. And with that, I can directly connect that to the other terminal of my relay module. So I'm going to zoom that in a little bit so you guys can take a close look at it. So again, loosen up the terminals and plug that connect in. Make sure you have a very tight connection. So now, having done this, my connection is done. With this, anytime I toggle the switch, I should be able to see the movement of the pole between the two throws, right? So first of all, I like to use my digital multimeter to test to make sure that I'm actually getting the right voltage that I did expect. So these are my two terminals. So I'm going to go ahead and turn this on to DC voltage. When using my digital multimeter, I always like to start from a higher number, even though I know that this battery is capable of 12 volts, but I have the habit of starting at a higher voltage in case there is any damage and I'm having a higher voltage than expected. And then I throttle my voltage down as and when I do need it. So by touching the negative terminal and the positive terminal, I am expected to get 12 volts. But because my switch is off, there is no voltage going through, and we can all see that it's reading 0 volts on my digital multimeter. So I'm going to go ahead and turn this on, or I can also take my measurements directly from the battery terminal and see what I'm getting out of it. So I get 12.8 volts, which is ideal to power that up. So that is right here, 12.8 volts. So which means that my voltage is ideal for whatever application I want to use that for. So now once I toggle the switch, I'm going to see that the relay is going to be toggling between the normally open and the normally closed. Let me get a very close shot of how this works. This is my switch. It's in the off position. The relay is in the normally closed state. So by toggling my switch to the on position, you're going to see that this is going to switch between the normally closed pole and the normally open because the relay coil is energized. So let's take a close look. So you notice as I introduce 12 volts to the coil terminals and I turn the relay on and off, which means that I'm allowing electricity to flow through the coil of the relay, I'm able to switch the pole between the two throws. And that is how relays are meant to work. Right. So now that we understand that by toggling the switch, I'm able to allow electricity to flow, let's see how we can let this simple switch toggle electricity between these two terminals. And to do that, I am going to be using these 12 volts LED strips. All right, so the green terminal is my positive and this is my negative. So what I'm going to also do here is I'm going to connect this because I want so the scenario that I'm going to be working in is when the relay is in the off position, I want to have my white light on. And when I toggle the relay into the on position, I want to have my green light on. How is that possible? Because we know that in this state, I'm going to grab my digital multimeter again and I'm going to explain something to you. I did make mention of the fact that any voltage that I introduce to the common is going to end up showing at the normally closed. So to do that, I'm going to put my digital multimeter on the buzzer so I can actually hear a buzz anytime I get continuity. So when I touch this common, which is common between the normally closed terminal and the normally open terminal, there's always going to be some amount of connectivity. And once I toggle the relay, you're going to see a change of state. So there is always connectivity between the common and the normally closed terminals. So when I touch this and touch that, notice how there is no reading, but this happens to be my closed terminal. And the reason why I'm not getting anything is the switch is in the on position. So, which means that the state has already been changed. But in the off position, now when I touch here with my common, which is the negative probe, and I touch this, I'm going to get some reading. And that reading indicates that there is continuity between this terminal and this terminal, and there is no break in it. When I move my red probe to this other terminal, I find out that it's in the open state and there is no electricity flowing through when we look on my digital multimeter. Why is that so? It is so because this relay is called the normally open terminal and this is called the normally closed terminal, which means between these two terminals, it's always going to be closed. And between this and that, it's always going to be opened. The only time the state is going to be changed is when I toggle the switch, allowing electricity to flow through the coil. Then this closed state is going to change state to be open, and this open state is going to become closed. All right, so let's take a look at it again. So at this point, my state is always closed, and I can see on the digital multimeter that I get some reading. Now, when I change the state by toggling the switch, the sound is going to go away, and I'm going to have an open state on my digital multimeter. However, when I move this here, I'm going to have continuity, which means that because the state has changed, whatever continuity I had from here came on this terminal. And that was as a result of this pole switching between these two throws. Now, based on the same principle that I just did explain, when I introduce any voltage, so in this case, I'm going to introduce 12 volts to this terminal, I should experience that 12 volts at that terminal. And how am I going to do that? I'm going to grab a piece of wire, and what I could have done was I could have taken it from the terminal of the battery, but I noticed that the terminal of the battery comes right here before it goes there. So ideally, I want to be able to take the terminal directly from there. So I'm going to use a different type of connector to split my voltages. So like I was saying, I'm going to need to bring 12 volts to this terminal because I'm going to be using the left side of the circuit. And for that reason, I have to bring my positive voltage, which is going to be my 12 volts DC. Now, what I'm going to do is I'm going to use one of these wire nuts. It allows me to connect 4 different components or wires to this and designate it either by a positive voltage or a negative voltage. So this is the positive voltage that was coming from the battery as indicated here. So that is my positive terminal coming on this. I'm going to disconnect this and change it and use a different wire connector. So I introduce the first one, I'm going to introduce the next one. And so this allows me to take a third wire and introduce that in here and close it. So now all I've done is I've taken the 12 volts input that I do have, and I'm going to wire it to the common terminal that is between the normally open and the normally closed. It actually doesn't matter the side of the circuit you want to use. So this side I am using this to control one set of circuits. I can decide to introduce a 24-volt circuit on the right side, and they're both going to act independently. So now that I've introduced my voltage in here, I should be able to detect the voltage present on this one because it is in the normally closed state. When the switch is in the off position, I want to have my white LED turned on. So I'm going to take the white LED and I'm going to wire it into the normally closed terminal. And then I'm going to take green one and I'm going to wire it into the normally open terminal. All right, so let's look at what I've just done. So I've been able to wire the two. The white one went into the normally closed terminal, and I wired the green LED strip into the normally open terminal. Notice that I have two black wires left. These two black wires are supposed to connect to the negative terminal of my power source, and which is the battery. So I'm also going to take another wire nut like this, and I'm going to bring a 12 volts from the battery terminal, and I'm going to wire that in. So let's get a piece of black wire, which I'm just going to strip real quick. So by using my wire strippers, I'm able to strip the jacket of it, and I'm going to plug one into here like this. This allows me to have multiple connections. And I'm going to take the negative from here and introduce that into my wire connector. So all the terminals that I connect to these are going to be negative or connected to the ground. So now with this being my negative, I'm just going to take one end of the white LED and the other end negative terminal of the green LED and also connect them in here independently, and do the same for this. Take that and also connect that in here. Well, so now as you can see, my white LED is on. And why is that on? Because I did make mention earlier that any voltage that I introduce on the common terminal of the relay is automatically seen on the normally closed terminal. And that is why when I connected my white, the positive of my white, onto the normally closed terminal of this relay, I did get volt current to flow from here to here. However, my green LED is still off. And it's because the switch is in the off position. When I toggle the switch to the on position, I am going to see that the green LED is going to turn on and the white LED is going to turn off, which means it's taking voltage from here and moving it over to this terminal. So let's take a look. So my green LED is on and my white LED is off. So by toggling this switch, I'm able to switch the voltage between the two terminals of the relay. And that's just pretty much how relays work. And this is just the basic explanation, and you can build upon this by doing so many different things with this. I can decide to connect a separate circuit on here to toggle other things. And the wiring is just going to be exactly how I did wire this. All right, folks, so this brings us to the end of another tutorial on how to connect an electromechanical relay. If you found this video informative, please make sure to subscribe to our channel, like and share our videos. And finally, if there are any questions or comments you have regarding this tutorial, please make sure to leave them in the comment section below. My name is Roland, and I'm with Delmi Solutions and Delmi Training Institute. Thank you for watching and be safe.